Hi everyone, Professor Muhammad Shah with you. Our main subject today is about anaerobic digestion biogas production process. But this one is a performance model. So, and we have previously we have a design model. The difference between design and performance is that in design model we are much caring about the design aspects such as volume, collection volume, the design of the system unit, and by the knowing of your production rate. And in performance model, we have the design aspects such as the volume, the collection volume, and the materials that you are going to add in the process, and we are going to calculate the production rate from the process. Open your Matlab firstly, and okay, go to your destination folder from here. Okay, this is my folder, and okay, so I set this is my design model and this performance model, and click here in this one current folder. Click here and try to select sort by name and group by type, so you will find the model is organized here. Okay, let's double clicking here. Okay, this is our main model. We need to specify some parameters. Double clicking on your mother block. Okay, and let's control plus, maybe emphasize a little bit. Okay, so I need to assign what is my collection volume. Okay, this is so important. I need to suppose I have collection volumes maybe 20 cubic meters and 100 cubic meters, up to you, and I have to supply this volume by some materials such as we call it feedstock types. Maybe one type may be mixing of some materials such as human, bird, fruits. It should be the type and total solids, and multiply or the number of this material. Suppose I have here type 1. I just added 5 types here. Okay, and you can add more types if you'd like. Suppose I have for the first one banana, for example, 20 kilogram of banana. Okay, multiplied by 10, and for this one I have another material. Suppose it's about 0.5 multiplied by 20. Okay, and so on. And I would like to the total solids for the number one, the type 1 here, type 1, suppose it's 16%. Okay, and the total solids for the type number 2 is about 20%. Okay, and what is your cost, interest rate, and plant lifetime? Maybe 10 years. Okay, hit apply. Okay, and let's go inside here. Okay, as you can see here, this is your block which contains the code, and you can use this code if you would like in your research activities. Okay, as you can see here, there are some inputs, and we have here some outputs. Saving, hit run, and let's see our outputs, what we have here. Okay, so based on the assigned inputs we have here, you can calculate total effluent required per kilogram. Okay, and total solids, total discharge, water mass to be added, should be added to the system, and gas production meter cube per kilogram. Okay, per total solid per day. Okay, as you can see here, collection volume is about 1 meter cube, and the sludge layer volume based on the total volume. Gas storage is about 1.94, and active volume it's about 14 meter cube. Retention time, we are going to calculate the retention time. To produce such amount of gases, we need almost 37 days to produce such gases. Diameter of cylindrical part, suppose it's cylindrical, volume of the top head, volume of bottom, volume of cylindrical part, height of the top head, height of bottom head, height of cylindrical portion, and biogas cost US dollar per hour, which is quite interesting. Suppose I would like to change, maybe I can add some or more parameters. Suppose I have maybe 10 multiplied by 10, okay, and the total solid should be for type number 3 here. So this is type number 3, maybe 0.25%. Okay, and hit apply and see. Okay, let's hit run, and okay, it changes our results. Retention time decreased because I increased the material, decreased by 10 days. What about the volume? Suppose I have 50 meter cube of total volume. I think the retention time, let's see if it has some effect. Yes, if you increase the storage volume, so you are sending a message to the unit that I need more gases, and based on the specific material that I already considered. So therefore the retention time will increase because you requesting more production rates. I'm sorry. Okay, you can control this dynamically if you'd like, saving your model in dynamic mode. Suppose I would like to control the volume. You can control the volume. Suppose I have different values of volume, as you can see, from 1 meter cube up to 100, and saving. I'm sorry. Hit run, and you can go into data. You have to consider all these outputs and send it to data inspector here. Okay, so if you run this with respect to the 100 values, let's check our model. Okay, so from 1 meter cube up to 100, let's hit run and see. Okay, going to data inspector, you can realize the variation based on your selection. Okay, total influent, no effect, total solids, diameter. This is your diameter increased because we increased the volume of your heads, volume of bottom head, cylindrical part, okay, head of the top, height of the top head. Okay, biogas hourly cost increasing, total discharge remaining constant. Okay, collection volume increasing, gas storage volume increasing, retention time increasing. Okay, so you can study the effect of increasing the total volume or number of materials or percentage of solids, total solids in your material, so you can get your result with respect to your collection volume if you would like. Finally, I would like to thank you very much for your interest in our model. Don't forget to like, share, and subscribe. Thank you very much.